Hi everybody, today I'm going to do some necessary upgrades for MCM5. Well, firstly I would like to add a waterproofing compound to the controller to protect it from moisture and water, to make sure that nothing will short circuit if the water goes inside. Although it will not, and I've done waterproofing, this is something I would like to do to make it more safer for the future. The next thing I would like to do is to reinforce the inner shell here where the axle is tightened to the shell. I will do it with a special plastic. I will show you it a little bit later. And of course I would like to do the battery upgrade for MCM5. I think it's not only my opinion, but also many of the owners of MCM5 will agree with me that there is a lack of battery for this wheel, because when you understand this wheel, when you feel it very well, you begin to ride not the fast in terms of speed, but very fast in terms of acceleration. And it gives you unbelievable experience in that, and in such way of riding, the battery drain is very significant, and when it comes to 40%, the wheel begins to signal you with beeps. It begins to hang up the pedals, so you have to reduce your acceleration and to ride slower because of the big battery sack. So that's why I would like to upgrade the battery to give it force parallel, to make it much more interesting in terms of less battery sack and more mileage from one charge. So here is one battery element. I've already put it somewhere like here, and so what I've seen that here it just goes up from this shell battery compartment only for 3 millimeters higher than its edge. And of course we can disassemble this battery. There is a very thick material, like sponge-like material, which is 5 millimeters right under this battery. Also on the cover there is a very thick sponge-like material, which is like 1 centimeter thickness. So when I will change these materials right under this battery and on the cover to make its thickness lesser, so I can put here the bigger battery, so it will be okay to have one parallel here as well. So how am I going to do that? Well, there are different types of such kind of improvements. The easiest way is to install additional battery here with its own BMS. So it will just work like standalone, and it will be connected to the main batteries in parallel. It will have symmetrical BMS, so it can charge and discharge from the same port. But I don't like this stuff because there is no understanding how balancing will be done between these batteries, because you know that the stock batteries are connected with some kind of synchronization cables. I don't know, maybe it is for balancing or something like that. Anyway, this is this means that the stock battery BMS are some kind of synchronized. But in my case, I would like to disassemble the stock batteries, this one and that one. Also, I've bought another MCM5 for spare parts. It's 60 volt edition, so I will disassemble battery from there, and from that 3 batteries I will assemble one big, which will be 20S4P. So what I will do, I will assemble here 10S4P and here 10S4P batteries. Then I will connect them to each other to make it like one battery. I already ordered a custom BMS, which will work with these 2 different parts of battery, like with the one. And of course I will connect all the balancing wires to these batteries, and I will get some more features like monitoring my battery via Bluetooth, like checking the balancing, how it's done. Also, there will be thermal sensors on the batteries, so I will know what is the temperature on my battery, and so on. I think this is the best way to assemble battery, although it is the most expensive one, because you have to reassemble everything, because you have to reconnect it, and of course it's a little bit more complicated than just adding one here. But in the end it will be much better to have such kind of battery I am planning. So right now I will disassemble those two while my BMS and wires are getting delivered to me, and of course I will balance each small part of it like with my IMAX B6 charger, and prepare them for the welding into two blocks. So I have prepared the donor MCM5 for battery extraction, and what I found out during the disassembly of this wheel is the shitty quality of Begode, how it was assembled. So on the other side, the stand for the axle, where it is tightened to the inner shell, was not tightened very well. So these four screws were okay, but these two ones were not tightened. I will put the picture to this video right now, so you will see it very well how it is not tightened. So I've put the pieces of paper right under these screws. They are 0.1 millimeter thick, so you now may understand how it wasn't tightened well to this part of inner shell. So in this case, if you will write like this without any preparations or without any checking of all the necessary joints, you will get this inner shell broken here, I think, or maybe even you will fall from your USC. So if you bought a Begode USC, first thing you have to do is to disassemble everything and to check all the screws and joints if you want to ride safely, otherwise you are in danger. So now I am going to remove this battery. It's right here under this construction. So first of all I have disconnected the power cable and the charging port. Next thing, I have discharged all the capacitors on the controller, so all you have to do is disconnect this main connector which holds the power cables, and then turn the wheel on with the power button like you do normally, and wait until it is completely dead. So this will avoid any damage of the controller by the short circuit if you touch something or if a screw will fall into it. So that's how the battery looks like. Its configuration is 16S2P. The BMS is non-symmetrical because the charge port is soldered separately. So I would like to say that if you will do the same job as me, you have to be careful while working with this knife to prevent the short circuit, because the main board of the BMS is not protected anyway with plastic or some kind of such protection. So be very careful, because those batteries are very flammable and dangerous. So now I will desolder these boards, and I will remove all the elements from there to balance them and prepare for the new assembly. So I've disassembled a part of the battery, and what I saw was kinda shocking for me. So you see here there is damaged this insulation because of these holders. They installed it like this, so they damaged a lot of elements. So I had to repack them once more. This is really shitty quality of battery assembly. So now I'm going to balance those elements and prepare them for new assembly. Finally, I received my new BMS with blackjack and hookers. This is how it will look like, the installation of it. The only problem is that in these wires, so I will resolder them to make them coming out from this side, like there. So I will have here all the balancing wires connections and the thermal sensors connections, and here will be all the power connections for my battery. This is Wh ANT BMS. It is designed for 20S 80 amps battery, so this wheel requires only 40 amps, so this is like twice more powerful for this wheel. I decided to choose this BMS for reliability and safety issues. This BMS has capabilities of balancing of the batteries. It has thermal sensors, so I will monitor the temperature of my parts of the battery. Also, it has a lot of features and settings for the protection, for the maximum current, and so on and so forth. And the main killer feature of this BMS is that it has Bluetooth module installed, and I can easily connect to it from my smartphone and monitor my battery state, and also I can change my settings on the fly whenever I need them. So that's how the side battery looks like. Here is the BMS board on the other side. So You have to be careful opening it. It's better to open from that side, not to short circuit something in BMS, and of course you have to take a lot of care not to damage the cells of the battery. So what I see here for now, before disassembling, I think the shrinkable tape, insulation tape of the cells is not damaged. As far as I see, I will look a little bit better when I will disassemble it, but anyway, for now I see that assembly quality is better, and maybe this is because of this battery had labeled as Gateway, and the other one I've disassembled previously was Begode. So now, as the battery has been disassembled, it's time to talk about assembly quality. When I disassembled the first battery I've showed you before, I noticed that there are a lot of damaged heat shrinkable insulation tape on the cells. About half of all the cells were damaged, so I have to repack them once more. But here in this battery I didn't find any damaged cell like this, so all of the 20 cells are perfectly mounted, so no damage to this insulation tape was done. And when I've opened the first battery, I've posted all the pictures of each cell to the EUC chat with my angry comments about the quality from Begode. And one of the users mentioned that the Gateway must be better because this is battery from Begode, it's so shitty. And yeah, this one battery is from Gateway, and its quality is much better. It's assembled in the better way, so nothing is damaged, and the Begode one was damaged. So what is the conclusion? The conclusion is that Gateway done the rebranding of the brand. The Gateway became Begode, and the quality became more shitty. This is obvious, like in this battery and in the new wheels they produce. Anyway, speaking about the battery and its cells itself, I've already checked all the cells with this multimeter, and I found out that the balance of each cell is perfect. So no questions from this side to this BMS, but I will change it, and I consider this BMS is a piece of crap because first of all, it doesn't detect the short circuit currents. So if you got your controller short circuited, the BMS will burn it away, or the battery will burn away. BMS doesn't care of these problems. And the second part of these issues is that this BMS doesn't have any temperature control. It doesn't have any sensors, so it's not about the safety usage of these cells because they are limited by the temperature limits, which you do not have to go above and on and below. And the best case, if you will have this problem, like you will get the degradation of your battery, and that's okay, you will just change it. And the worst case will become if you have the fire in this battery, and this is like very dangerous. Also, I would like to say that I do not advise you to do the same job I did with the battery disassembly, because first of all it is very time consuming. You have to do a lot of manual work to desolder everything, to remove the remains of nickel here and here from each cell. And of course this takes a lot of time to do it. And the second, my concern is that this work is really dangerous because if you get your battery short circuited during disassembly, as I mentioned before, it will not turn off, and you will get your battery burning like hell in your home or in your workshop, and this is really dangerous thing to deal with. So I already started my project, and I already disassembled 2 batteries, so I will continue to disassemble the third one and go with a new assembly. I have no other choice, but otherwise, if I knew that it is so time consuming before, I wouldn't go with that. I would rather sell those batteries on the market, buy new cells, and order a new assembly for me just to install it as a whole. It will like save me 3 times my time spent on all this working with the battery. So I finished disassembly of the upper battery. I decided not to record that since it's pretty much the same as the 67 volt version BMS. The difference is only in the cells quality and the configuration of BMS, and the configuration of battery is almost the same, so there was nothing to watch it. I must say that in the upper battery I didn't find any damaged cells as well, like in the 67 volt battery. I think that is due to the Gateway assembly of this battery. You remember that the 67 volt was Begode one and this one is Gateway. So the quality was good and I have no questions to the assembly of the battery. Right now I am going to discharge all these cells to 3.7 volts for storage, which is recommended for ion cells, and I will wait for the heat shrinkable tape delivery to repack the damaged cells from the first battery and then continue my battery assembly as a new one 4P version. While waiting for the materials and details for my battery upgrade, I decided to move to another wheel upgrade. It is the reinforcement of inner shell. It's not a secret that many users encounter with cracks in this area when they are jumping, get into bumps, or their wheel crashes somehow. So they have to repair the inner shell or have to replace it. So I decided to protect my wheel from these problems and I did the reinforcement. So I melted a lot of material here and as well as here, since my battery is getting bigger and as it's getting bigger, its weight is getting bigger as well. So this is important to have such kind of upgrade for the wheel. I did this reinforcement with this material. It's so-called polymorph material. You can find it on AliExpress or maybe in your local shop. The crucial point of working with this material is that you melt it and then put it like layer by layer here. But you have to be careful not to melt down the inner shell, because once it will start melting, it means your inner shell will be damaged and you will have to buy a replacement one. Unfortunately, I haven't found any videos related to this process, how to reinforce it with polymorph correctly. So I will show you this process in this video. On the other side, you see that I already did this side. I did a lot of practice. This was my first time. Maybe some of you will say that they could do it better. Okay, let me know in the comments. And if you can share the video with this process, that will be great for the community. Please do that. Before applying the new material to this part of the wheel, I need to prepare it a little bit. So I will disassemble the trolley handle and the beeper. So to make sure that they will not stuck in new material, and I will be able to replace them in case I need it in future, just in case of failure. And I will clean up this area with the spirit sponge as well to make sure if there were any oils or remaining dust, it will be removed. So I will be sure that the adhesion of the new material to the inner shell will be of the best quality. So I removed the beeper and found out that there is a double scotch tape, and I will use it to put it somewhere here. I will not use this shitty wooden screws which Begode or Gateway did in their fucking stupid process. I don't like these holes in this case with the wooden screws. So now I will continue the process of the surface preparation, and I'm going to scratch the surface with this small screwdriver just to make sure that the adhesion and the melting to this inner shell of the polymorph material will be better. I'm done with the scratching. I hope you see it on the camera, but if you don't see it, believe me, it's there. And I would like also to put your attention to a couple of moments. You see here I added extra washers, which also helps not to get extra cracks in this inner shell. And again, bad thing about the Godway or Begode, I don't understand why they did this. So you see here there are so-called cifering ribs. I don't know the correct words for this construction, but in Russia we call it cifering ribs. This helps to make the construction more rigid, and from this side these dumbass people removed the cifering ribs just to install this stupid beeper. I don't understand why they can't install this fucking beeper somewhere here and to leave this cifering rib here to make this construction much better, because this is really the crucial part of the wheel which needs as much enforcement as possible to make sure that your wheel will be durable and will work without any problems, even if you drop it, crash it, or jump on it. So to apply the material, I heat it up on my preheater of my soldering station. It has like this kind of a transparent consistency, but it's not liquid. It still has consistency like a honey, and it is possible to work with it with my fingers because it doesn't stick to anything. So you see that my gloves are sticky because of this material. So now I will take it with my screwdriver, just a portion of it, like this. Let's put it back, remove my glove. So now I will take it with my fingers. It's hot, but it's not burning, so it's possible to work with. Now I'm taking it and put it here like this, so forming the proper form. Some people may say that you have heated up more to make it almost liquid, but I prefer to take care of my inner shell, not to melt it down. So once the first piece is applied, I will heat it up with my heat fan to keep it temperature as needed, so it has to be liquid to put on more layers, and this is important for better layers melt down. So I work with my heat fan at 160 degrees, but I'm still taking care of the inner shell. So that's absolutely okay. So now, as my material is finished, I put another portion on the preheater to heat up, and I will continue to work with material, like putting these balls here and melting them down. Also, I would like to say that it is important to take care that the material will not go on the bolt head, because it is obvious that I will need in future to unscrew it. So I use instruments like this to put it away, and it is really easy to work with this material. If you've done something wrong, you can melt it down once again and change the shape. It's really easy. So let me show you how to continue with the next layers. So I take a little bit of material with my hand and put it here. So now I will melt them a little bit. So now they are getting transparent. I hope you can see it in the camera. And once those little balls are transparent, I just held them with my finger like this. And then heat it up again a little bit more. So this is how the process looks like. So I played a little bit with layout of my batteries, and now I will tell you more about it. So the upper battery is like stock, it's in the stock holder. The difference is just in the welding and its configuration. Now it's 10S4P config. So the nickel strips configuration here is also different from the stock. Also, there is now the balancing connector here. There is thermal sensor wire here, and of course there are power wires, plus and minus. Some of you might ask why did I took these connectors for the balancing. These are DuPont types. Why didn't you use this one, stock ones? And the main reason Why I don't like the stock ones here? Because if we look at the BMS connector here, it has 12 wires coming to the first connector, and from the upper battery I have only 11. So you see that 12 is being cut out and is not in use. So the main idea for this is just to simplify the maintenance, because if I will have like all wires coming from this battery and just one coming from the other, if I would like to change something in battery, do some maintenance, since I do have a smart BMS, I can really know what section has the problems in what part of my battery, and I can disassemble just a part of the battery, not the whole battery at once. And this is the main reason why I would like to disconnect just one part of the battery, upper or lower one, without disassembling everything. This is much better for maintenance if I need this in future. So speaking about the lower battery configuration, it has such kind of form. The main reason I did this layout is because if you add parallel here or here, you will have problems with cover assembly. The parallels won't let it fit here tightly on this part of the wheel. So only with this layout it is able to fit tightly on the wheel, and you can close the wheel as it has to be done like from the factory. So here I have also 10S4P configuration, like 3 parallels here, 3 parallels here, and 4 parallels here. So I will weld the lower battery like this. So the plus cable coming from the upper battery will be soldered somewhere here. Then there will be the first section, then second, third one. Then there will be connection here, the fourth, 6, 7, 8. Then I will make the interconnection in the battery here. So this will be 8, 9, 10. And here I will have like the main plus cable for my battery, which will come to the controller board. The BMS will be located here with the certain angle like this, because if you put it like this, right on this cover, it also won't let the wheel cover fit correctly here. So I will do like this. I've already checked with this kind of shape it fits correctly, and the wheel will close without any problems. Of course, some of you might say that we can get rid of this detail and just put the BMS here and this will be okay. But I do not like this idea, since this detail gives a little bit more rigidity to this part of the wheel. So I would like to leave it like this here and put BMS on this part here, like this. So that's how almost assembled battery looks like. I've added the balancing wires with this DuPont connector, which I will solder later on to the standard BMS connector. Here is my thermal sensor. I will add more wires here with DuPont connector to connect the upper battery thermal sensor, and this will go directly to BMS. So here is the minus of the battery, here will be the plus. I will solder wires here later on when I will check it on the wheel, what length do I need to not to make it more than I needed. I have assembled my battery with these rubber pieces here and here. Also, I've used this kind of special cardboard for the battery assembly. So now I am really sure that there will be no circuit here or here. So the battery must be safe. Later on, I will pack it in the standard shrinkable tape like this, so it will look like the stock one which comes from the factory. Also, I fixed my balancing wires here not to move around the battery but to be just in one place. Speaking about the BMS, I've soldered the power wires like this on the back of the BMS, because stock version was with wires coming from here and here on the sides of BMS, and this is not good for my layout, so I decided to change it to be like this. Also, I've reinforced the PCB tracks here with the copper wire because in stock version it was like 2 wires coming from here and I used just one. That's enough for me, but I wasn't sure in the PCB tracks, so I did the reinforcement like this. And while working with BMS, I made another decision for improvement for my layout. I decided to get rid of this cover, which is in the back of the BMS. So I don't really need it since there are no elements here. So here on the upper side, the cover is used as a heatsink for these elements and the balancing resistors. And here we do not have any. That's why I made the decision to get rid of this. To reduce the height of the BMS. So I will put the thermal compound here and here, and afterwards I will put this material here and put the BMS on its place. This will give me an extra small space with the height reduction of this BMS, so I do not need to put it like with angle like this, and I will put it like this here, and this is much better for my design and my layout. So that's the plan. Now I'm going to assemble it and we'll show you the result on the wheel.
Number one, drums go bump, bump, bump. That's right. That's right. Two step in for good luck and let me try this. Doom lock, lock, doom, doom lock, lock, doom, doom lock, lock, doom lock, lock, doom, doom lock. That's right. That's right. That's right. Two step in for good luck and let me try this. Doom lock, lock, doom, doom lock, lock, doom, doom lock, lock, doom lock, lock, doom, doom lock, lock, doom, doom.
While working with the wheel, I decided to make one more improvement of the cooling system. So I have disconnected the USB port, which I do not really use, and I do not like it because I do not charge my cell phone from it, and I do not like the port with the voltage which is on the front of the wheel, which is always with voltage. So I have connected to this port here on the controller board, which stands for USB, this additional ventilator. This is like a standard ventilator for 3D printers, which you can find on AliExpress. It has already necessary connector, but the problem is that the polarity is different. So I have resoldered it already, changed the plus and minus. So this ventilator will always blow directly to the heatsink of the main controller board and will help this little boy to cool the controller board. which will definitely help in hot summer days, which are currently in St. Petersburg. Finally, I finished the assembly of my battery, the lower battery, then I connected the upper battery. So now you see how it looks like here, and I will tell you a little bit now how it is connected and organized here. So this is the serial connection cable from upper battery to the lower one, which goes from plus of the upper battery to minus of the lower one. This is used by XT60, it will be somewhere there. So here I made all the balancing connections and the thermal sensor connection to the upper battery as well. I've covered all DuPont's connector with this sealant to make sure that it won't disconnect because of vibrations or something else, to avoid any problems during the rides. Also, I've added some sticky foam material here. This is needed to prevent wires damaged by cover during vibrations and ridings. Under this sticky foam material, there is another one XT60 connectors, which is used to main B- cable, which comes from the upper battery to the BMS. On the other part of the battery, you can see the main plus wire, which comes from the lower battery, since they are connected in serial. So here is the C- wire, which comes from the BMS, and it is connected through the standard Gateway wires. Since this BMS is symmetrical, it allows charge and discharge via the same port. So I used this Gateway cable. One goes to the battery, the other one goes to the charging port of the wheel, and it connects the controller board of the wheel. So here I've added a standard Schottky diode to my wheel, which I am doing for all the wheels I'm working at, to avoid any voltage on the charging port of the wheel. So to make it much safer, here is my fuse. So I've already activated my BMS. It's working really fine. Now the battery is charging. By the way, I noticed an interesting thing about this Gateway standard charger, which comes with the wheel. Here it states that it has 1.5 amps of power, and BMS shows that it's charging only 1.2. So it doesn't give you all the power you would expect from it. Anyway, now the system works fine. I will continue to assemble my wheel and try it out. I will not talk about the BMS because it is out of the scope of this video. So that's about it. It's time to stop this video and to continue to assemble this wheel and finally try it out on the street. If you like my project, please comment, leave a like and subscribe. See you later, guys.